Hello, it's been a long time since I've done a video, but in the intervening time, a new form of hype has arrived, and so it's probably a good idea to talk about it. Um, so, next. So, working in computing can be quite frustrating at times because you're busy doing your job, helping researchers do research, and you're a constant victim of these insane hype cycles, right? Driven by board leaders. Um, which sort of take over all of the headspace talking about computing. So for a while we've had cloud, which is just a fancy word for outsourcing. Um, there's the nutters who are into cryptocurrencies, and there's really too much to go into there. There's just like so many different levels of overhyping and fail and stupidity. Um, and also over the last decade or so, we've had a lot of hype around AI. AI is quite interesting because AI has had hype cycles for an extremely long time. So much so, there's this phrase called an AI winter, which means the sort of pattern of AI researchers promising amazing things and then getting funded and then failing to deliver and resulting in an end to funding and killing off whole language ecosystems, labs, companies, that sort of thing. Um, as a good example, here is a New York Times quote from 1958, right? The Navy revealed the embryo of an electronic computer today that it expects will be able to walk, talk, see, write, reproduce itself, and be conscious of its existence. So, even if we were delivering everything in AI that is promised, would be merely some 60, 65 years late. And we're not. So, as was true with all hype trains, there's this kind of unhinged response to it from people on social media. On one side, you have like the ridiculously pro people who are, oh, I've managed to create sentience. There's a glorious future enabled by machine learning. Um, you better make use of AI techniques right now, or you'll be unemployed. Um, and this is nonsense. It vastly oversells what we have technologies to do at the moment. Um, on the other side, you then have like two, I would say, distinct set of detractors. The first is really the first set in disguise, which is, LLMs are sentient. They're too powerful. You must regulate us. Uh, please invest in us, by the way. Our tool is just so good, you can't get away without investing in us. And then there's the kind of slightly unhinged language, generative AI is a plagiarism machine. It must be banned. It's destroying education, generating fake news, and so on. There's a much more regional position, I think, which is that large language models are entertaining toys. It's definitely true. And if you've played with ChatGPT, you'll know it's an entertaining toy. There's a possibility that they can plausibly automate completely worthless communication. So a lot of communication we do in business is saying things in long, flowery ways that are necessary, right? There's a brilliant cartoon of someone typing into generative AI, I want to apply for the job, here is my resume, and it produces this great big long flowing cover letter. And then at the other end, the recruiter puts that into an AI and it says, spits out the output. I would like to apply for this job. Can I have my CV? Right. So there's a whole class of communication around this, which is, we waste a lot of time doing and probably is irrelevant, but maybe not. But for this video, we're going to look at the first of these. So the goal I wanted to do for this was to run a pre-trained large language model on our HPC systems. Actually, one of my colleagues got this model up and running on their laptop, so if you have a reasonably chunky MacBook, you can get away with it, certainly. But what we need is a couple of things. We need an open source large language model. There are a lot of people claiming to have made open source models that are not actually open source because they depend at the base on a language model called Llama, which you need to apply with a form to Meta to get access to. But Databricks recently released this model called Dolly, which, if I bring up the web browser, bring up the right web browser, is a properly open source large language model. It's licensed under Apache. You can also get the dataset it was trained in. The dataset it's got at the moment is, as far as I'm aware, generated entirely by the developers at Databricks. So whereas a lot of language models have been crawling bits of the internet and hoovering up people's stuff. This is specifically set up by the people at Databricks. So it loses a lot of the such property dramas people have been having. You need access to sufficiently powerful computer. I've tested it on both 40 gigabyte A100 Myriad and on like a single compute node. The performance is roughly equivalent. Doing inference, you need a bit of Python knowledge. Right, so let's install the software. So we need a couple of things. We need to clone the repository that Dolly's in. We need a thing called the instructs pipeline, which you need to get from Hugging Face, and I'll explain that in a minute. And we also need to set up a virtual env with all the requirements for Dolly. Right, so the first one of these is fairly easy. If I bring up the repository, it's on GitHub. We can just pull that, sorry, just clone that. We'll get a copy of that. While we're doing that, I'll explain about the instruct pipeline thing. So if you go to Hugging Face and look at the setup for Dolly, it says you've got kind of two options for running it. There's the first thing they suggest, which is you import Torch from transformers, you import pipeline, and then you instantiate pipeline with a bunch of options, including this one, which the most security-minded amongst you will probably have a minor palpitation at this stage. What this actually means is the first time you run this, it will download a bunch of stuff from here, from Hugging Face, in a secure way over HTTPS, but that includes a Python script called instruct pipeline, which is basically the thing which sets up this pipeline. And so this is just saying it can download that and then run it. Like me, you're quite paranoid and don't like doing that. They have a second option, which is you download it manually from here. And if you click on it, let's take us to the blob. Yeah. I mean, you can see what it's doing. It just does some stuff setting up the pipeline. And then put it in your Python path. So that's the approach we're going to take because I'm a paranoid human being, but I've actually done both and they work fine. So back over here on Myriad, we have, I've actually already downloaded that earlier. We've got Dolly checked out into a repo. So what do we want to do next? We want to have Python. So we need to have a new enough Python for this to work. Unfortunately, one of the things you're going to have to understand is that there's been, sorry, sis. The march of time has meant there are successive incompatible versions of a library called OpenSSL. A bunch of the dependencies for this, the latest versions have deprecated the version of OpenSSL that's included with most sort of older Linux distributions, so Red Hat and some of the LTSs of Ubuntu. That means you need to use something that's a version of Python that's linked against a newer one. We have got that set up. If you don't have that, and the older OpenSSLs provided by distributions are patched for security flaws because they backport the patches, but they fail to check for features that is in the newer one. On Myriad, we've actually installed a newer version of OpenSSL and a newer version of Python, so you don't have to do that. So if we load those modules, we do module load open, or whatever is the current newest version. This is the current newest version on the machine at the time. And Python 3. So the first thing we're going to do now is create a virtual environment. You've seen this in so many videos. Oops. We'll create a virtual environment. I'll call it Dolly Runtime because that makes sense to me. Now we have some quiet dead air while virtual ends this thing. Set up, reactivate that. Okay. Right, so we now need to install the dependencies for Dolly. Thankfully, Dolly is a well-constructed package. And if we look in the folder in the repository we checked out, you'll see it's got a requirements.txt. So what you can actually do in Python is do pip install -r, and that will install all the packages that are listed in that text file. Actually, if you've not seen one of these before, it's it's a list of packages and versions. You'll see that this is based on Torch, which is good because as you'll know from previous tutorials, Torch works really well on Myriad and supports both CPU and GPU usage kind of on the fly, so you don't need to install any special stuff for it. Right. I'm going to let that go away and do its thing. You see I've done this before because it's using the cached ones that are in my pip cache. So one of the interesting things about Dolly is it's a much less advanced model than ChatGPT uses, right? It's much less advanced than GPT, which is kind of fun because it hallucinates a lot. And what I mean by hallucinates is it just makes shit up. ChatGPT has got a lot of guardrails in it, which will stop at you, asking it to tell you about software engineering techniques in the Qing dynasty in China, right? Whereas Dolly will just happily make up shit. It's amazing. It's a really good fun. It's a much more fun toy, I think, than the GPT stuff is as a result. It does, however, so it's interesting actually. If you look at the website, it does say it has some serious limitations, and it's definitely when you start building up conversations, you can get it into a kind of stuck state where it just kind of sticks the prompt back at you. So it's not really good at doing long, complicated conversations, but it's quite interesting to play with and to kind of understand some of the basic underlying features of these tools. Okay. So that step with the instruct pipeline, which hopefully you downloaded. What we want to do, if we're going to run stuff from this repository, is we want to put it in our Python path. And so the way we're going to do that is we're going to do export Python path equals where we are at the moment, Dolly, Python path. So this just prepends the Dolly folder and the current folder to the Python path. And the final step is we'll copy that instruct pipeline into that folder so that Python can find it. Right, so that's the model installed. So how do we use it? Well, I'm on a GPU node here. I have requested, and therefore I can see one A100 card. Let's have a look. I've put there are some Python files here, stage 1, stage 2, and stage 3.py. And what these are these are little programs I've written that we can pull into the REPL that will let us use the model in different ways. So if we look at the contents of stage 1, this is basically the most basic example of how to use Dolly, which is described in the on the Hugging Face page, right? If we bring that back. So it's this stuff here. So what do we do? I've defined a procedure that sets up a pipeline and returns that pipeline at the end. So it imports Torch. From that instruct pipeline module we downloaded, it pulls in the thing which generates those pipelines. Also pulls in some stuff from the transformers around tokenizers. We set up the tokenizer. We tell it we want to use this particular model. And again, the first time we run this, it will cause it to download all 23 gigabytes of the parameter files for this. It sets up the LLM. It tells it to use some very short floats. And then finally, it sets up the pipeline with the task text generation. This is an important secret step that's not mentioned anywhere. It took me a while to debug this. And this is necessary to get LangChain, which we'll talk about in a minute, to work when you're using the downloaded version of the instruct pipeline rather than the online one. The final thing you need, it doesn't say in Hugging Face, is you need the return full text equals true, and that's also required for LangChain. So at the end of this, you should get a pipeline object out, right? So let's do that. So if we do Python 3, we do from stage 1 setup main. Okay, and we do PL equals setup. This next step is going to take a while. So here we go, it started downloading stuff. First thing it downloads are these little JSON files, which was quite fast. And then it needs and now it needs to download that entire PyTorch model of the language model, which is about 23 gigabytes. Thankfully, Myriad is on quite a fast connection, so we're getting about 120 megabytes a second. That's quite good. It means you won't have to wait too long to do this. And once this is downloaded, it is stored in, and this is very annoying because it took me a while to find this. You might want to know where it's put 23 gigabytes of stuff. It's in .cache Hugging Face in your home directory. So if you want to clear it out, you delete that folder. It also, if you have the remote, if you choose to go the remote code execution, causing panic in the office, remote code execution route, it also puts the instruct pipeline.py in there. One of the nice things that playing about with the tool in this way does is it really demystifies some of it. The way ChatGPT is set up is quite persuasive, right? You get this nice web interface where you have a conversation with the tool. And the thing I really want you to get out of this video, apart from this is really easy to set up, is that it's not alive, right? There's not a continuing thought process going on. When you ask it a question, you're running a query like you would run on a database, right? It's just instead of using SQL, you are using something that looks a bit like English. And instead of it having a deterministic response like you would in SQL, it does a very complicated set of Excel curve fitting to create something that looks like English that maps onto what you said. And indeed, as I'm about to show you, until you kind of trick it into having memory, it has no memory of previous conversations, right? It really is like an atomic operation that you do. Right, it's downloaded the model. It's now going to load it. I believe this is the point where it's going to copy it onto the GPU, which takes a while. If I was logged into this node separately, you'd be able to watch the memory usage of the GPU go up from 0 to about 23 gigabytes, which is what's copying very slowly across the PCI Express bus. But functionally, we just kind of have to wait. The other aspect of this, right, is that even with this less good model, the hardware we're using here is immensely expensive, right? An A100 is in the region of 7 to 8 grand. Depending on discounts, VAT, education pricing, that kind of thing. One of the tricks, oh, it's finished. One of the tricks of the ChatGPT stuff is it makes it look really easy because it's all hidden away for you, right, in this cloud environment. And the cost of running ChatGPT to OpenAI is spectacular. Like it's country-sized budgets. Right, so we've got this object called PL. The way these are set up, you can in fact just tell them something like this, right? And it'll respond a blob of stuff. Let's do that. There we go. Tell me about the about sheep. Sheep are animals commonly known by humans. They're frequently milked to produce sheep's milk, which is milk-like substance created by a sheep. It's in fact milk, not milk-like, but anyway. And then it starts to get a bit one of the things I really like about the model is it will, if you give it a question, it will often have like a sane response, and it'll get progressively more unhinged, right? So it will say sheep are often victims of crimes because they're easily provoked and can be aggressive, right? Um, but these are independent steps. So if we it's completely atomic, so it has no memory, right? So it's given us a slightly annoying response because it's hard to come up with a sentence. Right. Why are they what crimes are they commonly victims of? Right. See, it doesn't really know. There's no linking this response, right? So it doesn't know what it said before. So this is an entirely atomic operation, right? You can't have a conversation with that. Right. Let's get out of this instance of Python. Right. Now, if we have a look, the next stage is how do we construct a conversation? So I spent a lot of time playing about with this on my own. And the CLUD you do is you modify the prompt so that each conversation step, you give it the history of the conversation, right? This kind of fakes it having a memory, but again, once you've pulled back that curtain and you realize you're not having a conversation, you're just giving a longer and longer query, you start to realize that this is, there is nothing going on. There is no magic behind the curtain. It's just an illusion. So in stage 2, so anyway, I spent a lot of time developing this stuff myself, and then I realized maybe I should just have a look around. And if I'd read down a bit further on that Hugging Face page, I'd have learned about LangChain. And LangChain actually makes doing conversations really easy. So stage 2 has the original chunk of code for setting up the pipeline, but then we have another procedure that takes one of those pipelines and then sets up a conversation. Right? It uses LangChain. LangChain can use the pipeline you've got, and then you can query that conversation, and it will rewrite the prompt as it goes, so that it includes the history. This debug or verbose option, which I've left turned on here deliberately, but set up so we can turn it off, shows you the things it's sending to the queries it's putting through the language model. So we want to, from page 2, set up pipeline, set up conversation. Okay, and we do PL equals. You notice that this time it takes a while, but it doesn't download that huge data set. It just does the actual setup phase. Right, it's done that first step, and now, as we said, we can just do conv equals setup conversation, and we'll leave that debug on because I want you to see the prompt. So conv has a method called predict. Now, very upsettingly, we probably won't get the response about the crime, so we won't get to interrogate that further. But if we do that, you'll see, because we've got debug turned on, it gives you a whole bunch of information. It says it's starting a new conversation. It constructs the prompt, so you see that it actually puts in an automatic, a sort of default. You can change this, a default. So we're looking for. It's got like a default prompt in there, which is the following. It's like the following is a friendly conversation, blah 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 blah, and then it puts in your query, and then it does the completion. So this is very boring. We didn't get to hallucinate some exciting crime. but maybe we can try anyway. What crimes a victim as you can see, what it's done here is we've got the previous history of the conversation in the prompt, right? We've got it's got the default prompt, what has happened, and then the current prompt. And from that, it has determined that we're talking about sheep, right? So it says sheep are victims of crime primarily due to be raised in farms which targets for theft, and so on. So it's got a conversation history now, right? Okay, this is not a very friendly way of talking to the computer. So in the final stage, what we're going to do is write a few lines of code which will give us a little sort of read, execute, print line thing where we just talk to it and we get a conversation, right? Oops, getting ahead of myself there. So stage 3 has the same two previous routines, but now written a little routine called simple REPL. It also takes debug, so it can pass through all the, so it passes that through, so we can tell it to either print that all that debugging information about the prompt or not. I've put some timing in there, so you can see how long it takes to set up and how long each query takes. And as a very simple loop, right? It gets a line of input. While that line is not equal to by, it loops forever. It there's a conversation. It gets it tells the conversation object to predict based on that line, reads another line, and so on until it equals by, at which point it will exit. Right. Um, okay, and then we just need to do go. So it took 64 seconds for it to set up. And it's given us a question mark, which was the prompt we put up here. So now we can say, tell me about sheep. Why are they often? So yeah, it all works. We have created a slightly limited version of a chatbot, right? Get out by typing by. That ends the function. I'll show you what it's like with the debug turned off. Um, let's choose a different animal. So this time you see it's not printed out any of the conversation debug stuff, right? One of the things I find interesting in playing with this is the wildly different response times. There are times when queries can take several minutes and times when they can take a few seconds. And that's part of why I put the timing output stuff in, because I was kind of keeping track of it. There we go. So whereas previous queries took maybe 8 seconds, this one took 82. So yeah, and you could tell how in this case, you could, easily trick yourself into thinking of a conversation. And that's the other thing, right? So I think part of the reason there's so much hype about this, oops, is that humans assign human behavior to things that are not human. There's a very famous chatbot which massively predates machine learning called Eliza, which is a sort of virtual psychotherapist in it's built into, amongst other things, the Emacs text editor. Maybe I'll show you that actually. Give me a minute while I try to remember how to do it. Right, I took a quick foray into the internet, and I believe I do Emacs and then do meta X. No, that's not a meta. Oh god, we're now in the what is a meta in this version of Emacs problem. Okay. You have no meta key. So I don't use Emacs, I use Vim because I'm cultured. SGEX does it. There we go. You get this chatbot, right? Right, and it's actually it's a very simple rules-based thing, right? It doesn't take very long for you to be convinced that it's not real, but people assign humanity to these things, and it's part of why these things are so persuasive. And I just think you need to look at the way it is, in fact, just a query engine. Understand that it's just maths. There's nothing going on there. It's not a lie. I'm sorry, you have not created strong AI, and that's the message I want to leave you with.